Okay, so today we're going to go over the first problem, the first practice problem of section 1.2. So the first problem is asking us to uh, find how many $20 bills we need to circle around the Earth's equator. So first, the problem gave us equator, right, is equal to 40,075 kilometers. And the weight of the $20 bill is equal to 1 gram. Also, the length, right? The length of the dollar bill laying down flat, so like this, right? Is going to be 6.14 inches. So already we see some differences in the units. So there has to be some sort of unit conversion that's going to need to be done in order to get from here to here, right? So let's write down the conversion. So 1 kilometer is actually equal to 39,370.1 inches, right? And 1 ton, because part 2 of the question asks for the weight of the dollar bills, the $20 bills in tons. So 1 ton is actually equal to 907,185 grams, right? So given that, let's do part 8 first. So problem 1.1, part 8. Let's do part 8 first. So again, just to do some bookkeeping, let's write down the Earth's length at the equator in kilometers. So we need to find how many inches do they equate to. So what am I in inches? We can see that, let's see, 1 kilometer equals to approximately 39,370.1 inches. So it's a unit conversion over here. So we can simply just multiply. So what we're gonna do is we're gonna do 40075 kilometers, right, over 1 multiplied by 39370.1 inches, and then that's what 1 kilometer equals to, right? So we have this dimensional analysis set up. We can plug it in into our calculator, and then we're going to get a value. Let's call it x, because I want to do all the calculation at once. This way we avoid any rounding errors. So now we know a $20 bill, as given in the question, is going to be 6.14 inches, right? So we know that we have a total of x inches, right? And then we want to find how many dollar bills there are in x inches. So we divide it by the length of each dollar bill, laying flat like this. So the next thing that we want to do is basically write out the equation explicitly. So we're gonna just write this down. So we know that this unit is going to be in inches because we know that they cross out, right? And then that's going to be divided by this value over here, so 6.14 inches. This way the inches cross out and we're left with the number of dollar bills, right? Okay, so that will give us a number around, it's going to be a long number, so I'm going to write it down here. So the answer of number of dollar bills is going to be 256,963. Sorry, that's supposed to be a comma. 641.28. And if there's something that we need to know is that we want to cover the entire Earth, right? And it makes no sense for us to cut, I guess, 28% of a dollar bill. I mean, a $20 bill. So in order to respect the $20 bill and to use some logic, we're going to round this up. So instead of 256,963 641.28, we're gonna have 642. So we round it up by 1. So this way we have enough to wrap around the equator of the Earth, but at the same time we're not, I guess, destroying currency, money. So this is the number of $20 bills, right? Okay. So let's continue to part B. Part B, we're asked to find the weight of the dollar bills in tons. And since we're using a new page, I'm going to write down the unit conversion for ton one more time. So 1 ton is equal to 907,185 grams. At the same time, we remember that we have a total of 256,963, 642, $20 bills, right? So we know that one $20 bill is equal to 1 gram. So we know that there's a total of this much grams of $20 bill. Why? Because to find how many grams there are, we basically multiply this entire number of dollar bills by 1 grams. And anything times 1 is that number itself. So we're left with 256,963, 642 times 1 grams. As I said before, since it's 1 gram, I'm not gonna write grams. Doesn't make grammatical sense. And then that is going to be multiplied by this conversion over here. So ultimately, we want to end up with ton, right? So a trick to do that is whenever you have a unit conversion, just write the unit that you want at the top, right? And the unit that you don't want at the bottom. So we want to get rid of grams, right? So we can do that. And then we have approximately 283.253 and a whole bunch of random numbers, tons of $20 bills when we stack them up together. So just to, I guess, round it up nicely, we can say 283.25 tons of weight, right, from the stack of $20 bills that can wrap around the Earth's equator, right? You don't have to write a whole statement like this. I'm just writing it out because I just did. So yeah.